Oliver, second day, NBAA 2023, out on the static display. Just watched you fly a little while ago. Tell us what's happening with Volocopter.
Well, first of all, it's really exciting to be here today and to be able to fly at NBAA and showcase our aircraft to the public. What's happening at Volocopter? We are in the middle of the type certification of our Volocity aircraft. Expect type certification to be completed in the course of next year, starting operations in Paris at the Paris Olympics. What you see here is Generation 4. We are type certifying Generation 5 of the vehicle. It's slightly bigger, has a horizontal tail attached, which was creating significant improvement on the energy efficiency, and some further details then on the inside that you do not directly see.
You mentioned certification next year. How has the FAA or various administrative agencies treated you when you're dealing with vehicles that, well, they haven't seen before?
So there was a good reason why we started to go into the interaction with the authorities already a long time ago. That was December 2017 when we filed type certification application with our home authority, which first is EASA in Europe. And shortly afterwards we kicked off the validation process with the FAA, so that jointly we can learn about these new vehicles. For us, being a European-based company, EASA has developed the so-called Special Condition VTOL, which is a full set of certification requirements for this novel type of aircraft. And we are using that as a certification base now for the validation in the US. In the US, that's 2117B process for those who are in the details, and we are categorized there as a special class rotorcraft.
What have been the surprises in that process for you?
One of the first biggest surprises for us was once we started to go from remote controlled flying of our very early prototypes towards setting a fully trained test pilot on board of this aircraft. He was flying it. His first comment was he never had such a boring first flight of an aircraft, as it's
every test pilot's dream, boredom.
Exactly, that's what you want to have, an uneventful test flight. I've been test flying myself as well, so exactly that's what it needs. But the second thing he said, okay, we have to do it over again with the flight controls. That way, how you have optimized it from remote flying, that doesn't work for a pilot on board. We have to do it in different ways. And that was for me, one of the strong lessons learned, which I think our fellow peers are also going through. Once they go with a pilot on board, you will learn new things. These type of vehicles, they are not a helicopter, they are not a fixed-wing aircraft, they are a vehicle on its own.
Well, the obvious question to any of us trained in Rotorcraft are what are the reversionary, what are the emergency modes in the event of any kind of power or powertrain interruption?
So the emergency modes here are dealt with by same certification requirements as you have for the commercial airliners. We need to demonstrate the so-called catastrophic failure to be as improbable as 10 to the minus 9. And we need to demonstrate that there is no single failure that can lead to catastrophic. What does that mean? We have 18 rotors. We can lose any 2 of the rotors and we are still capable to continue flight, to continue climb, to make safe landings, make a go-around. So everything that you would do for a twin-engine or multi-engine aircraft as well. That's what we have to demonstrate. You have to demonstrate that all the control systems are not just redundant, but also dissimilar, so that we have different hardware from different suppliers with different softwares programmed by a different team on board, so that we just cannot run into a simple common mode or common cause failure. That's what we are bringing in, and with this redundancies that we are having, triple redundant flight controls, 9 individual battery packs that can drive all of the 18 motors, we are reaching exactly these targets.
Outstanding. Fascinating, actually. So how are we going to see this in the commercial world? Where will it first be seen? How will it be used? And what do you think the future is?
So with this type of vehicle, we will be starting our commercial operations in Paris next year. It's very tight still, but it looks good that we are able to make this. Shortly afterwards, we will go to Rome, have first operations there, and then rolling out into the other countries, as has been made publicly available. We are speaking with NEOM, we are speaking with Japan, and we are now here to also speak with the US, where we can put up a proper base here in this area. How will it be? We clearly start off with this type of vehicle, 1 pilot, 1 passenger. That's little, yes, we know, but that's what the technology today is able to do safely and can cater then for all the reserves that you need to have available. Next step will be then the next generation of the vehicle, which is already in the making, which will allow for more occupants to come on board and then become more efficient. And that's also where we think around the beginning of the 2017s, when the numbers really then start to pick up. Until then, it's gaining experience. We need to get out, we need to learn how this works in the field, we need to get the feedback from the customers to further optimize the system. There are many promises out there of different projects of what might come in the future. That's the first step that is realistic and that can happen and will happen next year. It's the safest design of vehicle that you can do. We have no mechanics on board, we are not tilting, we're not changing flight control laws. That was the safest design we could find to start with it. Safety is first, and from there we're going to explore. Also our vehicles will grow, capability of the vehicles will grow, and looking really forward to that bright future.
Thank you very much for spending time with Aero-News, sir.
It was my pleasure, thank you.